What is music? Well, it's obviously sound. So what is sound? Sound is basically vibrations in the air. Objects vibrate, and this vibrates the air, and we pick up these vibrations with our ears. Most of these vibrations are very complex waves consisting of very many frequencies all mixed together, like this. They don't sound pretty. But some things vibrate with an almost pure single frequency, and that's what we call a note. If you look at this pendulum, if I pull this to one side and let go, it swings back and forth at a certain frequency, i.e. a certain number of times per second. Similarly, if I pull this guitar string to one side and let go, the same thing happens. It swings back and forth, only obviously much faster. I happen to know, as that is the note A, it's swinging back and forth 110 times per second. When things swing back and forth that fast, they vibrate the air and we hear the note. In every single musical instrument that exists, there will be something vibrating at various frequencies, vibrating the air and making the notes. On a guitar or a violin, it's a string or a wire. On a saxophone or a clarinet, it's a reed. On a trumpet, it'll be the player's lips. On a flute, it will be a column of air. Now, there are an infinite number of possible frequencies that things can vibrate at. So how do we get from there to the notes we use for music? We have to somehow choose certain frequencies to use. Okay, I will now invent music. Imagine music doesn't exist. I've stretched a wire between 2 points, I've plucked it, I've decided it sounds nice, and I've managed to discover that it is vibrating with a frequency of 110 Hertz. That's 110 swings per second. I have invented one note, but I want more. So I wonder what would happen if I halve the length of this string. That's there. When I do this, I find that the string vibrates twice as fast, 220 Hertz instead of 110. I've invented a second note, and I notice that these two notes seem to go well together. I play them on different strings. Compared to like these two, horrible. They almost sound like the same note, which is hardly surprising when you consider that one is vibrating exactly twice as fast as the other. I've got two notes then, one twice the frequency of the other. So what shall I try next? I feel that there ought to be some more notes in between the two I've got. So I've tried twice the frequency. What about 1.5 times the frequency? 1.5 times 110 is 165 swings per second or hertz, which I happen to know is that note there, normally called an E. And that's the original note, and that's the new one, 165. And they also go together quite well, not quite as well as the original two, but quite well. Not surprisingly, because they are mathematically related. So I've now got 3 notes. So what's next? So what about if I multiply the new one that I got by multiplying by 1.5? If I multiply that by 1.5, well, that comes to more than 220, and I want to stay within the 2 original notes. So I will multiply that by 1.5 and then halve it. And that comes to 123.75 Hertz, another note, which actually I know is this one here. So if I carry on like that, and I could also try 1 1/3, 1 1/4, etc. After some time and some increasingly hard sums, what I discover is this, and this is the crux. These methods do not produce an exact set of notes, but they seem to approximate to a set of 12. A set of 12 notes between 110 and 220. In fact, this applies to any note or frequency, and the note that's twice that frequency. if you do the fractions, multiply by 1.5, etc., you always get this approximation of 12 notes, 12 divisions between one note and the notes that's twice the frequency.